Okay, so I want to start with a review of utility, as I mentioned, utility and marginal utility. So utility is essentially a way that economists can quantify the pleasure that comes from a good or a service. So you get a certain utility from eating a banana, you get a certain utility from drinking a beer. Depending on if the utility you get from eating a banana is greater than the utility you get from drinking a beer, you can say that I prefer bananas to beers or vice versa. And that's really all utility is a way to quantify and rank different choices. And specifically the action that you want to do is you want to be able to rank them. So an economist might say that the utility from drinking a beer is X, the utility from eating a banana is Y, X is greater than Y. All that says is that I prefer beers to bananas. Okay, so if given the option and similar cost or whatever, I would prefer to drink the beer to eating the banana. Okay, and whatever the value of X is, let's say you solve the model, X comes out to 7, doesn't really matter. Okay, what matters is that you just know that X is greater than Y so that you can rank your preferences. Okay, and economists typically assume that, your preferences are rational. So if X is greater than Y and Y is greater than Z, you could say that X is greater than Z. So if the third thing was like an apple and an apple gives you a utility of Z, you'd still prefer the beer to the apple. It wouldn't magically switch because you introduced a third good. Okay, they assume that preferences are stable, that you always prefer X to Y, or you prefer beers to bananas, even if you have a certain consumption bundle of, let's say, 100 beers and 100 bananas. That might not be the same utility that you get from it. You might prefer 100 bananas to 100 beers, even though you prefer one beer to one banana, because the utility functions might be a little different. Maybe you get a linear, like your utility for bananas is always going to be 5, but your utility from the second beer might be 1, and your utility from the third beer might be negative, right? Because you get drunk, you might actually be displeased by drinking extra beers. But you can say that your utility is stable in that the utility for one beer and the utility for one banana is always going to be, the utility for one beer is always going to be greater than the utility for one banana, no matter, if you add in a third good or, the time of day is different. And the reason for that assumption is just it makes your models more internally consistent so that you're not constantly putting conditions on it's, 6 o'clock in the morning, so my utility from drinking a beer is suddenly lower, which it might be true in real life, but, for the sake of abstraction, typically economists will assume that utility is stable. Okay, so the first is that consumers are rational, that utility is stable, and that those are kind of really the underpinnings behind decision making for consumers. Like utility is like a basis for ranking things, and of course, like I hinted at before, utility isn't always going to be rational. It's not always going to be stable. Or maybe not that utility won't be, but consumers won't always be rational. Consumers won't always have stable preferences. They're not always going to prefer bananas to beer or vice versa, just because, their mood might shift in a particular scenario or something. And, you can model for that. It's just that economists typically don't. Because when you start getting that granular, it's probably because you want to solve a particular problem. Otherwise, you want to abstract away from it because being that granular doesn't really add a whole lot to, most models that economists will use. But all this is to say, utility is really just a way of ranking different choices that consumers will face. Okay, so if your utility for one good is greater than your utility for the other, consumers will tend to go to that first good. Okay, and I said consumers, but it's not just consumers. It can be any agent in any model. Okay, utility is a very broad concept that is going to be applied to most models, whether it's game theory, whether it's micro, macro, international trade, whatever. Utility is pretty much used as like the standard building block for modeling. Okay, and then from utility comes the second concept, okay, and that's called marginal utility. And really all marginal utility is, it's the utility that you get from consuming the next additional unit. So remember how I gave you different utilities for beer? And I said that the first beer might be like, you might give you a utility of, let's say, 2, okay? And, you know, like I said, 2 is just a random number. But let's say the first beer gives you a utility of 2. The second beer gives you a utility of 1. The third beer gives you, or one beer gives you a utility of 2. 2 beers gives you a total utility of 3. 3 beers gives you a total utility of 3.5. Okay, so let me write this down because it's very easy to lose track, just like I just did. So utility from 1 beer equals, let's say, 2. Utility from 2 beers equals 3. Utility from 3 beers equals 3.5. Okay. Marginal utility is essentially a way of taking this and seeing what the utility from the second beer alone is. Okay. And that'll be 3 minus 2. And the utility from the third beer alone is going to be 3.5 minus 3, or 0.5. Okay? So basically, if you're standing at the first beer, you've already consumed the first beer, how much utility are you going to get from consuming the second beer? That's your marginal utility. Okay? So, marginal utility from the second beer is 1. The marginal utility from the third beer is 0.5. Okay? And I chose a particular fashion for the utility I get from beer. So if I were to just plot this out, okay, and on the x-axis I have B for beers, and on the y-axis I have U for utility, and the utility I get from beers in particular. So at the first beer, second beer, third beer, I get 2, and then I get, what do I get from the second beer? I get 3. Oof, I cannot keep my hand straight. And then from the third beer, I get 3.5. Okay. So let's plot this. And apologies, because it's not going to be exactly drawn to scale, but it should look vaguely curved, and you'll because I'm not a good drawer, this is terrible, but I do have a better drawing on the slide. But it should be vaguely curved like so, okay? And if I were to take the total utility, you can see that it's increasing. Utility, the y-axis, is going to be increasing for all beers, right? Even though the curve kind of starts flattening, the total utility is still increasing. Okay, the slope is always going to be positive, but the marginal utility is going to be decreasing. Okay, the marginal utility going from the first beer to the second beer is going to be 1, right? The marginal utility from going from the second beer to the third beer, I went over a little bit, is going to be 0.5, and the marginal utility going from no beers to 1 beer is going to be 2, right? So the slope at any point of this graph, like if you were to draw like a line going out, and then a line going out, touching the graph at only like one point, but the slope at any point in this graph is going to start decreasing and decreasing and decreasing, and then presumably at some point it's going to reach 0, but as the limit goes to infinity, if you're familiar with that term. But all this is to say is that I prefer the first beer to the second beer. I would rather have, I'd rather have 2 beers than 1 beer, but if I could relive the experience of the first beer twice, I'd prefer that to drinking a second beer, if that makes sense. Okay? I remember my first beer. Well, like, in that sense, like you want, your first beer is going to be the best beer. Your second beer is going to be meh. Your third beer is going to be fourth beer, you're going to be like, oh, I'm drunk. And then maybe because it's beer, it's your fifth beer, you're going to be like, yeah. But generally speaking, that's not going to be the case for most goods and most people. And like the big example for, this shape of the utility function, where as you go on and on and on, the slope goes closer and closer to 0. We call that diminishing marginal utility. But the example that you can give is, you give a homeless guy $100, he's going to have the best day of his life. You give Bill Gates $100, he'll never, ever even notice, right? If he suddenly loses $100, he probably makes and loses maybe $1 million a day, probably more if I'm being honest, just by having investments in certain things. I'm sure he sees $1 million swings maybe in the span of a half an hour. So if you give him $100, he won't even notice. Okay? So if it's your first $100, you're going to be psyched for it. If it's your millionth pair of $100 or whatever, your millionth set of $100, you're never going to notice. And that's diminishing marginal utility. The impact from the last set of $100 is going to be nothing, but the impact from the first set of $100 is going to be awesome. Okay? So that's the law of diminishing marginal utility. While utility generally increases, the marginal utility decreases. Okay, so this is your utility function drawn a little bit better. Here's your marginal utility. So your first beer is going to have utility, or your first sip of beer is going to have utility that's really high, and then as you drink more and more sips of beer, the utility you get from that next sip is going to be really, really low. Okay. There's one other point I wanted to mention before I move on. I just kind of lost the thread a little bit. At any rate, so marginal utility is going to be, if you were to like really isolate marginal utility in like a true economic sense, when you take like upper level math classes, your marginal utility is going to be tracked by the slope of the utility function at every point. So if you had like your slope here, if you like draw 1 point here, your slope is going to touch the utility function at exactly 1 point, and this is going to be a really high slope. And if I took the slope here, it would touch that point at only one. It would touch the utility function at only that point, and the slope would be kind of flattish. And if I were to look at the slope here, it'd be very flat. Okay, that's your marginal utility. It's truly speaking, it's the slope of a tangent line, we call it, a line that touches the utility function at only 1 point. And if that makes no sense to you, don't worry about it. But if you are, a little more familiar with math, and maybe you've had a little bit of calculus, or you're at least familiar with calculus, or you want to get familiar with calculus, that's really how we treat marginal utility in future economics classes. But again, don't worry about that for now. For now, just know that your marginal utility is going to be the utility going from like the 0th good to the first good. Okay, the utility change going from here to here, or from the first good to the second good. What's the utility change? Okay. All right, so that wraps up the review of marginal utility, regular utility, and the law of diminishing marginal utility. So let's move on to kind of applying them.